Hi there, this is Math 148, still on section 12.5. More differential equations, more diffie-q. Yes, you could do this for a whole semester, but we're not going to. Okay, this is question number 15, and the question looks like this. We have the derivative of y divided by the derivative of x is equal to x squared over y. So the problem is we have x and y's on different sides. Do you see that? We have x dx down here, x squared up here, dy up here, and y squared down here. This is no good. We don't like it. That's a no good, not an x. So the first thing you want to do is get x's and y's all on the same side. So get the variables and the derivatives all on the same side. So remember I said shirts and skins? So you want an x side and a y side. So get the variable on each variable on its own side. So the way we do this is we can actually multiply the sides by dx and dy. So you can just use it like a variable. For example, I can multiply this by dx like that. And then this looks like this. That would be dy. The dx's cancel. Kind of weird, but it works. And on this side, we'd have x squared over y dx, like that. Still a problem because I have a y down here that I don't like, so I can multiply this side by y, and the y's cancel. And now we are good. Now we have y over here, dy, and x squared dx. Your book calls this separated form. So in this case, we want to separate x and y. They don't get to play together. They have to sit in separate parts of the room. And you can recognize separated form by this side now has all y's and this side has all x's, which is great because now we can take the integral. We'll do it on this page. So we have y times dy, this is our separated form, times x squared dx. And now we want to solve this differential equation, and it's a differential equation because there are these d's in there, d for differential or derivative. Take the integral of both sides. The integral of this side is y, add 1. It's 2, 1 over 2, plus some constant, plus some change. The derivative of this side, add 1. X cubed, 1 over 3, plus change, plus a constant. And the answer then is 1/2 y squared equals 1/3 x cubed. And then remember that constants go together. Since we don't know what the numbers are, they just become some other new constant. I say plus change, but it's actually a constant. And this is your answer. Again, you can leave the answer in this form, and that's part of the trick with these problems, is learning to just figure out how far you have to solve it. But in this case, leave it in that form. Let's look at another one. This is question number 25. Again, looking at differential equations that may not be in the form that you want them to be in. X plus 1, you're thinking, I don't want them to be in any form. I want them to leave me alone. But you don't get that choice. Okay, so again, the problem here, you see there's x here, dy, dy. We want an x side and a y side. And you always want the dy and the dx to be in the numerator, essentially. You don't want them in the denominator. So we're going to multiply both sides by dx to get rid of the dx here, like that. And then we're going to put the y on this side, so divide both sides by y. Here, sorry, let me do this step by step. So we have x plus 1 times dy is now equal to y dx, and I want to leave the dx and dy up top, essentially, so we'll leave them in the numerator, but I want to move the x over to this side, so divide everything by x plus 1, and then divide everything by y, divided by y, or times 1 over y. So my final problem now, when I rearrange everything, is 1 over y dy is equal to 1 over x plus 1 dx. So I brought the y onto this side, the x plus 1 over here, dx over here. So this is this is what they call separated form. Again, I separated x and y. They weren't going to behave, I had to separate them. they didn't behave. So in this case, we haven't taken anything. We haven't solved the derivative or done anything except get it in a better form to make it easier to use. So now that I like this form better, I can just rewrite it here. 1 over y dy equals 1 over x plus 1 dx. To solve this, again, we take the integral. Integral. Looks like a swoopy F. So the integral of 1 over y dy, flashback, is natural log of y plus a constant, plus some change. And this comes from section, I think it's 12.3, with the integrals of logs and exponents. And this one, remember, we would do this formally. We'd say, well, I want it to be 1 over something. So I'm going to let u equal x plus 1. The derivative of u is just 1 dx. Yay! So I could rewrite this one in the form of u prime over u dx. So the reason I did that is now that's equal to the natural log absolute value of u plus a constant. I'm being very formal. Probably most of you will just switch right away. We have to substitute back. Natural log absolute value of x plus 1 plus a constant. And over here we have natural log absolute value of y plus a constant. And at this point you're probably thinking this, how do I solve this problem? And the answer is, I would just leave it. At this point, just leave it like this. Actually, leave it like this. Put your constants together and write it like this. Natural log absolute value of y is equal to natural log absolute value x plus 1 plus some constant. Your book does this fancy thing where they add the constant in and they use the property of logs to say, well, that's like multiplying by the constant, and then they end up with some other thing that's like c bar equals some other constant. But don't worry about that so much. For the purposes of a test and for my purposes, I'm happy if you just leave it like this. You don't have to simplify it any farther. So that's how you do that one. So look these over and let me know where you get stuck. These are the sort of problems I would expect you to do on a test. Good luck, you guys.